Hello and welcome. This is the first S2. Yeah, we're moving on in the world now. S2 topic video. This is going to cover all of binomial distribution. Now, it is fairly easy to split this topic up into smaller videos, but after all, where's the fun in that? Okay, so what I'm planning to do is this is just simply talking you through the bits of binomial distribution. So got a list here, so I'm going to explain what we actually mean by binomial distribution. Now, see, the more people who paying attention would have spotted this binomial distribution already on the board. Okay, well, obviously that's just a reminder of what we mean when we're talking about binomial distribution. Now, that's the C2 analysis of it. There is another little bit that I didn't include there, but it's mainly used in C4, so I didn't really include it because, well, to be honest, it's just a bit of a background, reminding you what it is. Okay, and then I'm going to introduce to you how they note down in, well, weirdly enough, mathematical form in the exam. They're likely to do that in a maths exam, believe it or not. The way that it is written and is shown to be binomially distributed. Okay. And I'm going to therefore also go on to say there's two ways in where we calculate the probability of a binomial distribution. One of them is simply just using a formula. Now, I'm going to give you a bit of background to why that certain formula is used and what the little bits mean, okay? But I'm not going to be going into how we derive it because, again, you don't need to know that. Okay, and then the other way is just using something called the binomial cumulative distribution function, which is a table almost like the one in normal distribution, but obviously it's in binomial, so different things in that. But in essence, it shows you the probabilities up to and including the probability to be 0.5. That'll make more sense when we go through it. But I'm also going to show you how we use the same table to calculate probabilities that are larger than 0.5, even though it only goes up to 0.5. And then I'm going to finish off really just with a few equations, just showing you what the equations for the mean, expected value, which is the same thing really. The mean, which is the expected value, so you do need to remember that. And then the variance and standard deviation, which obviously the standard deviation you should just pick up from your S1 knowledge, okay, from going from the variance to the standard deviation or vice versa. Okay, so the first thing that I'm going to talk about, well, what the hell do we actually mean by a binomial distribution? Now, you may be going, well, this is binomial, but it certainly hell isn't a distribution. And even the other formula which I didn't include on there, sorry, is definitely not to do with some kind of distribution. So what the hell is it? Well, essentially, to put it in a quick context, it's just a series, this isn't the proper definition, it's just build up to it, obviously. This is just a series. It's just a situation where there's either a yes or no answer, and we can display it on a tree diagram. Okay. Now, if there's a yes or no answer, what I mean by that is it's either a success or not. So an example might be coming first in a race. You either do or you don't. Okay. Now, obviously, you can come second, third, or whatever. But the principle is you either win or you lose. Okay. And the principle, obviously, if you follow that method, then you can keep going off losing forever and ever. Now, it's the first one you achieve whatever result is you want. So if you want to win, obviously, hopefully you do. You're not going to race. You're not going to do any more races once you've hit that win. Okay. Excuse me. No, it's not a really good example, but you get the idea. Okay. Now, there's a few. Obviously, that's very basic, a very generalistic idea of what a binomial distribution is. But we're in math, so we have to put some logic to that. Okay, I'm not logical at all, but you know, we get that kind of thing. So there's four characteristics is a better word for binomial distribution. So you know, if a distribution exhibits these four characteristics, okay, then it is binomial. And the reason we're going over this is because there's one or two questions through a couple of past paper questions I've seen on binomial distribution that say, well, what type of distribution is this? Now, obviously, we're going to go and look on later on, look at other distributions such as the Poisson distribution. Okay, but there's a couple of things that distinguish it to be a binomial distribution. Okay, so there's four characteristics that you need to be aware of. Okay, so I was talking just then about it's either a success or a failure, and it's the first, and it's the time you keep going until you hit your success. So in terms of, you know, either you get your A star or you don't, or you win a race or you don't, or you die or you live, or you think you're on top gear or you're not. Okay. Anyway, so I was just trying to check the clock. So anyway, it didn't work. So the principle is, what I'm saying here, build up's first characteristic. We could have you know, a win or a lose, for example. Obviously these would have probabilities associated with it, but you get the idea, okay? So then we'd stop when we hit a win, but you can quite clearly see we could keep going on forever with the lose, okay? So if there was no characteristic, there was no feature that defined how many outcomes, this is what they mean by, you know, the number of tree diagrams, essentially, the number of trees, branches, okay? That leads us to our first thing. This is the first characteristic. There is a fixed number of outcomes. And this will be stated, obviously, in your question, if it is binomial distribution, where it says there's, you know, a dice is rolled 5 times, for example. That's obviously just an example. So there's a fixed number of outcomes. Otherwise, because if there wasn't, we'd be going on forever and ever. So it has to be some kind of fixed number of outcomes. Now, I kind of already mentioned the first, sorry, the second characteristic, which I probably should have put first, but who really cares? I certainly don't. I've said this, either you're a success or you fail, or you win or you lose. Okay, so there's always them two options, okay? So the way I've written it down there is, there's 2 outcomes, there's always the same 2 outcomes. Oh, that's a wrong way of putting it, actually. Fixed number of outcomes, could I word that better? You see, I've listed this down, I've only just realised now as doing the actual video that it does, you might get confused. So when I say fixed number of outcomes, obviously what I mean is, you know, there's a fixed number of amount of times you throw a dice, for example, you record results, okay? But there is always 2, I'm trying to think of a better word now, okay, so two options on each outcome. That's maybe a better way. Okay, what I mean by this is a fixed number of outcomes, okay? You know, we only throw a dice 6 times, for example, but, you know, if you were using the idea of throwing a dice, then the 2 options on each outcome must be you either get a 6 or you don't, for example. So that's what we mean by 2 options on each outcome, which are always success or failure. Okay, and obviously the success or failure, you'll put that in the context of whatever question it's asking, whatever, you know, question it's asking, obviously. So if it's talking about, you know, murdering a few people, and you don't talk about planting a couple of flowers, okay? But anyway, maybe that's just going to get sarcastic. But anyway, getting on away from that. Okay, so 2 options on each outcome. So the success or failure, and there's a fixed number of outcomes. So they're 2 characteristics we've got so far. The other one is that the I'm going to call it. Obviously I do know the characteristics. I'm just trying to word it better because I didn't trust myself then. The trials are independent. Now, I'm trying to use different words so that you don't think each of the you know, a couple of points say the same thing, because these all say totally different things. Okay, so what the hell do I mean by trials are independent? Well, apart from me trying to sound like a tosh, you know, idiot, the trials are independent. What we mean by that, what I mean anyway, is that one outcome does not depend on another one. In other words, they are independent, okay? So, you know, the loss of... So, obviously, you've got success or failure, and then if you've already thrown a dice once and you've not got a 6, you've obviously been a failure in life, the next throw does not depend on how the previous throw went, okay? So, basically, the probabilities... This leads us to our 4th characteristic as well. The 4th... So, the trials are independent. That just means the next throw or the next event does not depend on the previous one. Okay, so your next throw doesn't depend on the outcome of your previous throw. Okay, which leads us to our next next point almost. I'll try to link it in hopefully. The next point is the probabilities of each outcome are the same. Okay, so the probabilities don't change. So, what do I mean by this? Well, obviously there's a different probability for having a successful outcome than a failure. Now, it might be by chance that they are purely the same, but this point's saying the chance of having a failure on your first go is exactly the same as having the probability that you will fail on your 1000th go or 700th go or however much of your life you decide to waste. Okay, so the probabilities don't change. It doesn't matter how many throws you do, the probability of failing will always be the same. The probability of success will always be the same. Now, the point I've got listed for that, if that doesn't make sense, the probabilities don't change, is that the probability of success will always be the same. Okay, or obviously because you've only got the reason I put that and not just the probability of success will always be the same. Well, there's only two outcomes: probability of success or probability of failure. And if the probability of success is the same, well then they both have to equal 1, so the other one must be the same as well. So obviously the probability of failure must always be the same, and probability of success. Each successful outcome has the same probability. Each failure outcome has the same probability all the way through the tree diagram. Okay, and you should know, because obviously, as I said, we can list a binomial distribution on a tree diagram because there's a positive. There's only two outcomes at each stage. Okay, each time we throw a dice, for example, and you should know the probabilities in a tree diagram tend to be independent anyway. Okay, I think you should know that from S1. Obviously, you know, it could depend, but basically probabilities don't change. That's what I was trying to get across there. Okay, so these are the four characteristics of binomial distribution. So a question you might get in the exam is you might get a situation. Okay, I can't remember what question it was, but if I have a look, I might mention it later on. But then I might not, because I might not be bothered. You might get a question that says, using this, that will give you a situation, but it won't tell you what probability distribution to use. Okay, and it will say, you know, what's possible probability distribution for this situation. And if it's binomial, it has to fit each one of them four characteristics. Now, there are obviously other characteristics for other distributions, okay, but if it fits all four of them, it's going to be binomial. Okay, so there's a fixed number of outcomes, two options on each outcome, so it's either a success or a failure. The trials are independent, so obviously your chance of probability of getting a failure on your first go is exactly the same as failing on your 7th go or 12th go or whatever. Okay, and the probabilities for each outcome don't change no matter how many throws or whatever throws of the dice you do or however many times you attempt it. Okay, so there are four key characteristics that you just need to kind of remember. But as I said, I personally linked the bottom two and the top two together because they kind of are the same point but just split up into little bits at that point, if it makes sense. So you can just remember 2 points in terms of what the outcomes are like and their probabilities. Okay, so obviously the last two to do with the probabilities and the first 2 points to do with the outcomes or what happens to the options. Okay, so as I said, that was just kind of what do we mean by a binomial distribution. Okay, so it's just a bit of an insight. Okay, so the next point I want to mention is how do they actually write in the exam if they don't tell you it's binomial distribution, but they're going to write some mathematical sign to show you that it's binomial distributed. What would it be? One sec. That was a good cup of tea. No, I made it myself. You know, compliment myself. So, if this is the first time doing binomial distribution for you, if it's just a recap, I don't really care. But if it is your first time, I just help it out. So, in S1, we learned about that we learned normal distribution. I think it was written like this, where x and then there's a squiggly line, and then there's n and was it mu and sigma squared. And what that said there was that x was normally distributed with a mean of mu and a standard deviation squared. Okay. Now it might not be a number squared. It might just simply be 9. Okay, which obviously had to square it to get the standard deviation. Now that's what it's written in terms of normal distribution, but we're still looking at distribution, so it's going to be written in a similar way. Okay, so that's normal. So if you are redoing S1, just a bit of a recap there. But obviously it's binomial is slightly different. So we start off with the same thing, x and the little squiggly line. But because that's normal, it's got n for normal. Obviously we need b for binomial. But we're not going to have mu and sigma squared. In other words, we're not going to have the mean and sigma squared in the little, almost looks like a little set of coordinate that. It's not very good English, but anyway, don't really care. So binomial distribution. Okay, so what we look at in the case of binomial distribution, so we look at the number of trials. Okay, so it's number of trials n, or you want to label that as the number of outcomes or whatever. So it's the number of times you throw the dice if it's a dice throwing thing. Okay, and we also have a probability of success, which we label P. So it's a probability of success. Okay, and we just simply write that as NP. Okay, so it's a lot simpler, and you just have to remember that is how they write binomial. Okay, so that's what it will look like, and that's obviously just comparing it to normal distribution. So you can quite clearly see the link there. The mathematicians are pretty lazy. They're not going to invent something too radical. They're just going to come with the reason and say, oh well, it fits in with the pattern of the old. No, you're just being lazy. Okay, so, but thankfully for us students, it means we have to learn less. Okay, so anyway, that's how they would draw binomial distribution in an exam. Okay, so, my sheet. Okay, so what I'm going to go on to now is the two ways. Obviously, there's a couple of things they might ask you to do with binomial distribution. I mean, so far I've just said what it is and what are the characteristics and how they write it. But obviously, they're not just going to ask you about that. They're going to ask you to calculate probabilities, okay? And they're also going to ask you to calculate mean, variance, and standard deviation. So this is really more applicable to the actual questions. Okay, the first little bit was just simply telling you what it is. Now, the first way that they might ask you to, the way of calculating a probability. Okay, so I'll write the equation down and kind of explain it. So the probability that x equals r, where x is just simply, an outcome, okay, and r is so p of the probability that x equals r is the same as saying probability that x equals little x for but obviously that would be what you'd write for normal distribution, okay, but you write p is equal to p of the probability that x is equal to r. That's what you'd write for binomial. That just means that probability that x is a specific outcome, okay, the specific outcome r, which will become more apparent when we start doing questions on it, okay, and that is equal to n choose r, n cr, times the probability that there's going to be a success, so p, and then the probability that there's going to be a success, which is this p here, okay, so that means the same thing, to the power of r, okay, so I'll go through what all these mean in a minute, times q to the power of n take r. That's not very good, are they? Okay, so hopefully the first thing that I'm going to go through is what this n choose r means. Now hopefully you should recognise that, as I said, from C2. And what that means is I think it's the factorial of n, which whatever n is, say n was 3, the factorial of 3 is equal to 3 times 2 times 1. Okay, so that's just what a factorial means. So it's a factorial of n over the factorial of r times n take r and the factorial of whatever that comes to. Okay, so that's just what we mean by n choose r. Now, that's a probability that is a success. What does this q mean? Well, it's a probability of a failure. And that should, I know we've not said that in this little box thing, but hopefully it should come across as quite easy. Well, you know, the total probability will come to 1. You can't have a probability greater than 1. Like some people stupidly think you can have a percentage greater than 100. You just can't. Okay? In the grand scheme of things, okay? Well, this Q just means it's a probability of failure, which for many of people in their exams, such as me, that's going to be quite high. But anyway, what you simply do is it's 1 take the probability of success. So if P was 0.94, it's 1 take 0.94, and Q is 0.06. Okay, so it's really kind of obvious stuff. But what does this n mean? Well, n, this little n here, is the same as this little n over there. It simply means the number of trials. Sorry. Okay, so that's what n means. And this r here is just simply this r here, where the probability that x equals r. So r is just an outcome. It's just an achievement. Okay. Instead of I have explained it better somewhere else. Sorry, 1 second. Sorry. 1 second, just double check something actually. Sorry, I'm just looking for a good example of what this art is in terms of giving you a bit of an insight. Okay, so if it was saying, if you were given a sample of 10 mugs, for example, this is a question of June 2006. If you're given a sample of 10 mugs and asked to find, the probability of getting the 3rd mug, okay, then what you're trying to achieve is the probability of getting that 3rd mug. Okay, so R would be 3, and obviously because it's a sample of 10 mugs, is an opportunity of 10. Okay, it's 10 trials essentially. N would be 10. Okay, so that's what all that's saying. That's a very, very simple explanation. Now, I just want to go into a bit more. Now, obviously, you know, that's a probability of success. That's a probability of failure. But why have we got this N choose R business? Why the hell have I put that in there? Apart from, it's part of the equation, obviously. What this shows, and it's only really applicable if you draw a tree diagram, is it's the number of paths. Okay. Now, what I mean by that is there's a number of paths in a tree diagram. Okay. So, as I said, this is the success probability of success, probability of failure. Now, obviously, you've only got in each outcome of a tree diagram of binomial distribution, you've either got a successful outcome or a failure of an outcome. Okay, and obviously that generates different paths. So if you start at the start, weirdly enough, you can go for success and then another success. Sorry, no, that's wrong. Sorry, I do apologise. Sure, it's you can start, you go for a failure and then you go for a success, and that counts 2 paths. Okay, but this just shows you if you wanted to get the 3rd mug, okay, how many paths would you take? Okay, so obviously, if you wanted to get to the 3rd mug, it'd be you wouldn't get the 3rd mug the first time, not the 2nd time. You get it the 3rd time, or whatever it would be. Okay, so as I said, you enter that NCR. Now, I'm assuming you know that from C2 how to enter it in your calculator, but I'll just come round to the camera and show you. If you haven't done it, or you're doing this is further maths in your first year and you haven't yet done this N choose R business, which is obviously related to Pascal's triangle, and I do think I mentioned its relationship in the binomial distribution video for C2, which if it isn't yet up, I will be putting it up. Okay, so I'm not sure if you can quite see it because obviously I've got a light on over there. So, okay, so you've got your standard. This is just a basic just a standard calculator. Okay, so for this particular calculator, the button for NCR is just above the divide. You can't quite see it, I don't think, but it's in the yellow writing just above the divide symbol. Okay, so what you do, if I was going to put 10, choose R, in other words, 10 to be N, R to be 3, okay, what I'd do is I'd type in 10 first, okay, and then I'd do a shift button and get the NCR button, which is above the divide, because you get that weird C thing, and then you press 3, you press enter, okay, and it gets you 120. Okay, so, oh sorry, I think I've got my calculator in the right mode there. Yep, doesn't matter. Okay, so you get the idea, that's how you're going to input it if it asked you to. Okay, but as I said, that's just a very, very basic example there. So that's one way of calculating the probability of getting, the third mug. But it might not ask for the probability of getting a third mug. It might ask for the probability of getting less than the third mug. Or that was just an example. It's not a very good one. Getting less than a score of 3. If that was the probability, if 3 was a score. Okay. So obviously you wouldn't be able to use that. Well, you might do, and you could work it out for individual outcomes. So if there was only 10, if there was 10 outcomes, okay, and it went from 0 to 10, okay, then obviously you could do the probability of 0, probability of 1, 2, and 3, and add all them up, okay. But that'd take a long time using that method. So that works if it's just simply asking you to work out the probability that x is 3 or whatever it might be asking, okay, for the individual terms. But if it's asking you for a set of terms, okay, that's going to be a little bit more challenging to work out. Okay, I do apologise. Now, if you have the formula sheet handy, now I've handily printed off myself this gorgeous looking book, basically just a formula sheet, okay. So for this S2 formula, again I'll try and bring it up to the camera, but I mean I'm not sure how this is going to work, to be honest, but I don't really care. So I do apologise. Obviously, sorry, this is the smoothest bit of the video, but that's just your basic S2 formula sheet, okay, where obviously it tells you what we're going to go into something later on, which has got the mean, the variance, and you could work out the standard deviation from that. But there's nothing else it gives you in the S2 formula sheet. Now, what I want, so obviously it doesn't give you that, so you do need to. Does it? I don't think it does anyway. Yeah, it doesn't give you that. But this is what I'm more interested in here. See this one? Sorry, I think I might have pulled out the wrong one. Ah, there it is. There's something called the binomial accumulation distribution function, okay, and what this is what we're gonna, this is another way of working out the terms, okay. Now I don't know if you can quite see it, but what it says there is the tabulated value is the probability that x is basically it's saying if you choose x to be little 3, if you choose little x to be 3, sorry, it shows the probability that x is less than 3. Now, these p values here, okay, so the first column, the columns are showing the p values, and these p values directly relate to the p that's in this example of binomial distribution, which just says it's a probability of a successful outcome. Okay, but as you can see, it only goes up to 0.5, and that's something we're going to deal with a bit later on. Okay. Anyway, so obviously this n here just represents to that n in the exam. Sorry, that n there just in the. So I'm really good at this. Just represents the n in that word in there. Okay, so that's all that little n means. Now, as I said, I don't think you can see this quite well, but you can get it on your fancy computer thing. Okay, so anyway, what you would do, okay, so obviously that says n equals 5, so all of this group all these values here, up until obviously the next block, okay, all these values represent when n is equal to 5. Sorry, when n is equal to 5. But you go, well, what are these individual values here? So the 1, the 2, 3, the 4. Well, they're values of x, so they're individual values of that little r there. Okay? Yeah, so when x equals 0, obviously you could pick up that says the probability x is equal to r. Now, obviously it will say probability that x is equal to little x, and basically this little x here is of these x's here. Okay, so it says find the probability that x is less than 3. You would look in the row 3 here, and then whichever probability you've got here, the probability of a successful outcome, you would look for the probability of successful outcome, whichever column that is, and then you would look for the row which says x is equal to 3. Remember, this is for the probability that x is less than, that big X is less than the x you're choosing. So what it means is if you've got x to be 3, it's the probability that x is less than 3. Okay, so you would look in the row for 3. Okay, but obviously you've got to correspond that with the column which you've got the probability of successful outcome for. So if you're saying the probability that a successful outcome is 0.15, then you would look in the third column here, and if you're asking for the probability that x is less than 3, then you would look in the third column, the third row of the column which says the probability of successful outcome is 0.15. So that was the reason I brought that up, is because the questions you might get asked will require you to use that table. So hopefully that was just a bit of an insight into how you use the table. Okay, now I do admit maybe you couldn't quite see the table so well in that explanation, but really that's just I wanted to do that so I could illustrate how to answer these next bits of the question. Okay, so say if you just want to, I mean, I'm sure you've copied that down anyway, but I'll just give you a second if you do want to copy that down, because I'm going to be rubbing, especially this little bit at the bottom, and I'll rewrite that function of the binomial distribution out at the top. Okay. Now, as I did mention at the start of this video, I will be doing some, because obviously I don't think I'll be able to put up some S2 past paper videos before the exam, or I will try, and I'll definitely get it up for next year, but obviously it'd be irrelevant if you're not doing it next year. Okay, but it's just I'm going to be adding some past paper questions about binomial distribution onto the YouTube channel, obviously, but as I said, this is just a theory video, so I will be giving you some more highlights of how to use that idea of what I've just shown you, how to use the table, but I'm not going to be giving you any specific examples in terms of questions that you might get asked, okay? But I'll give you enough so you can answer, obviously. Okay, so let's bring out the distribution one. So okay, so that's what they would write, as I said, that x is binomially distributed, okay, where the n is the number of outcomes and p is the probability of a successful outcome. Now, I talked about the fact how they might ask you. I came up with the probability that x is equal to r, and I said that was n choose r, etc, etc. But you could also answer that in a slightly different way, okay, which is using that table, okay. So if they said find the probability that x is equal to 3, for example. Now, as I said, you could use that other formula that I've just shown you, the n choose r formula, and that's perfectly acceptable. However, another way to do it would be, if we're going to use that table, well, the table values say that the probability that x is less than or equal to 3, okay? Well, obviously, it doesn't just give x is less than or equal to 3, but it gives x is less than or equal to a given value, okay? So what we'd have to do to work out the probability that x is equal to 3 is do the probability that x is less than or equal to 3 minus the probability that x is less than or equal to 2, because the difference between them is obviously the probability that x is 3, because the probability, say if we've got x values of 0, 1, 2 and 3, for example, sorry, you could go on 4, 5, 6, whatever, okay? If we want the probability that x is less than 3, if we just simply put that in and said that was probability that x is equal to 3, well, quite clearly it isn't, because the probability that x is less than 3, according to that distribution there, is probability that x is 0, x is 1, x is 2, and x is 3. But if the probability that x is 2 includes the probability that x is 0, 1 and 2, if we take them 2 away, what we're clearly left with is a probability that x is less, that is x is equal to 3. So that's one way of simply, and obviously if you were to do that, obviously to work out the probability that x is less than or equal to 3, you would going to need this table again. So I'll probably have to come around and just show you again. And this is pointless and it's probably not going to work. I probably look back and go, what an absolute tosser for not getting the focus right on the camera. So trying to high-tech stuff. I'm going to alter the focus now. In the video. Sorry. Oh, check that out. Oh, yeah, it's worked. Okay, so yeah, you can't. That's how it focus, but that works. Okay, so the question says the probability that x is equal to 3 is the probability that x is less than or equal to 3. Take away the probability that x is less than or equal to 2. Now, I know I've just taken it out of focus, and now you won't be able to see this, but let's just say that the number of outcomes, okay, is 3. Sorry, no, that's a bad idea. Sorry, the number of outcomes. Yeah, so the number of outcomes n is equal to 5, okay? And the probability of getting a successful outcome is 0.10, okay? So that's just an example there. So if we use the values that the n, little n is equal to 5 and p is equal to 0.1, we can use this table. Okay, so we want to get the probability that x is equal to 3, and we do that by having the probability that x is less than or equal to 3 and taking it away from the probability that x is less than or equal to 2. Okay, and to do that we have to use this table. Okay, so I do apologise, I haven't got the steadiest hands in the world. But what we've got to do is work out the probability that x is less than or equal to 3 first. So we need to use the two values we've got given, that the n is equal to 5, so we choose the first column because it says n is equal to 5. And we've also got the information that the probability of success, little p, is equal to 0.1. So quite clearly, we choose that column. But we've got to choose, we're in this box here, but this just says n equals 5. It doesn't mean we choose this first row. This n equals 5 just says all of that, okay, is to do with when we've got 5 outcomes. So 5 trials, if you want to think of it like that. These individual rows are to do with this row is if we've got x is 0, x is 1, x is 2, etc. But our x value that we want to find is 3. Remember, when we've got an x value here, this doesn't mean the probability that x is 1, and that's the probability. It says the probability that x is less than little x. What it means is, if we've got x to be 3, it's the probability that x is less than 3. So we look where x is 3. And you've got to remember, we've got the probability of success of 0.1. So we look in this column, we match it up with x is 3, and we get 0.995. Okay, and we've got to take away from that the probability that x is less than or equal to 2. Now we're still in this column, okay, because there's a probability, it doesn't say the same, it doesn't change of that the probability of success is 0.1, so we still stay in this column, but we've got to find the probability that x is less than or equal to 2, which is just simply the one above, okay? Now, what we do is we want the probability that x is 3, so we do 0.9995 minus the 0.9914, and that will get you your answer, okay, for the probability that x is 3 with the bits of information that I've just mentioned at the start. Sorry, one second, we go back in focus. Right, hopefully that's worked. Okay, so hopefully that gives you the basic idea of how to use that table. Now, it might just simply ask for the probability that x is less than 3. Okay, in other words, you just simply do one of the two steps that we did. You don't need to take anything away from it. Okay, but that is a potential question they could ask. Okay, so what we've done so far is assume that the probability is 0.1. And don't know if you could quite see it from the table, but obviously you can check online as well. The probabilities of success in that table only went up to 0.5. But obviously this is maths, they can make it more difficult. And we can still use that table in a more difficult manner for the probabilities of that success that are greater than 0.5. Now, to be able to do this, I just want to introduce a little table to you. Now, as I said, when you do so many of these questions, you won't need this table. But it's nice to be able to interpret why we're using it. I'll give you a bit of an explanation. I'm going to introduce another variable, y. Now, don't get this too associated with the x and y axis, because we're not looking at graphs. There's nothing to do with that. Maybe I've just confused you when you didn't need confusing. Sorry, I'm not sure if I'll edit that out, but it doesn't really matter. Okay, so I was just saying then, we might have a situation where we have a probability of success which is greater than 0.5. So for that, we might get a situation where it is something like, x is binomially distributed. Say we've got n is 5, but the probability of success is 0.9. Okay. Well, if you look in the table, quite clearly, there's no value which is associated with 0.9 of p. So what we do, obviously, that's the probability of success. The only other potential outcome is the probability of failure. Okay, so therefore we come up with this other value we call y, which is also binomially distributed with the same n, 5, but it's 1 take 0.9, in other words, 0.1, and that's this chance, that's probability even of failure. Okay, so we come up with a relationship between these two variables, which we can put in a table, sort of. Now, you don't necessarily need to draw this table, but it's just to help you get in the mindset of what we mean. Now, I said, ideally, what we want, we've got 5 trials, okay, we've got 5 attempts at this, okay. So what we come up with here is we come up with the successful outcomes and the number of failed outcomes. Okay, and basically, on each column, they've got to add up to the total number of trials that's been taken place. In other words, the total number of trials at this point is 5, okay? So they've both got to add up to 5 in each column. Okay, so what we do is, x is the number of successful outcomes, okay? So obviously we want 3, doesn't matter. This is relevant to any x value, okay? Depending on what this p is representing the successful probability of success of whatever it is we're trying to get, okay? Obviously that hint's been successful. Okay, so because we've got n is 5, the maximum number of successful outcomes is the number of outcomes we're going to have, okay, which is 5, okay? So you go from 0 to 5, because you either have no successful outcomes or 5. So 0, 1, 2, 3, 4, 5. Okay? However, I've just said, why is this other variable where it talks about the number of unsuccessful outcomes, if you like. And as I said, these have got to add up to 5. Okay? So you can quite clearly see, if you fill this in, we'd be going the other way around. So 5, 4, 3, 2, 1, 0. Okay? So you can either have no successful outcomes and 5 negative outcomes, or you can either have 1 successful outcome and 4 negatives. Okay? And when I say negatives, just mean not successful. Okay? So that is just a table that helps you to think of it. Okay? Now obviously, it's not always going to go up to 5, it might go up to a lot more than 5 or less. That's just an example. Okay? So basically, this doesn't go off the x values you've got. Okay? So even though we've got x values of 0, 1, 2, 3, 4, I haven't put 0, 1, 2, 3, 4 in there because we've got 0, 1, 2, 3, 4 in terms of potential outcomes of x. Okay? I put 0, 1, 2, 3, 4, 5 because that's the number of outcomes that we could have in terms of, you could either get 1, 0, no successful outcomes, 1 successful outcome, 2, 3, 4 or 5. you could have every single throw that we put as a successful outcome. Okay, so that's why I put 0 to 5 there. And obviously, y, as I said, is the opposite of that because it's the number of unsuccessful outcomes, but you've got to make them equal 5 overall. Okay, so really it's just a working backwards table there. Okay, so what we're going to do now is apply this so we can use that table. What I'm also going to do now is just pause the video to plug in my camcorder. Just be a second. Okay, so hopefully you understand that. Just kind of rub this little bit of rubbish out. Anyway, so if it said find the probability that x is less than 3, okay, so I put it there, okay, the probability that x is less than 3, well, the number of outcomes, successful outcomes less than 3, would be these, okay, so probability of 0, 1, 2 and 3. But obviously in this situation we know that the probability of success for x is 0.9. Okay, so it's very high. We mostly can't look in the table for this, but we can look in the table for y. I know it's not in terms of y, but if we turn it the other way around it will make sense in a minute. Therefore we look at these values of y. So the probability that y is 5, 4, 3 and 2. Okay, now what that says really is, therefore we said that we want to find the probability that x is less than or equal to 3. But that's because it's the same part of the table, if you can look at it like that, is saying that the probability of y is greater than or equal to 2. Now obviously the table isn't in terms of greater than or less than, it's in terms of less than or equal to. Okay, so I know it's obviously not in terms of y, but remember this y is just another variable. But obviously we have to look in the table as though we're looking for x. This is why it's kind of a bit confusing. Now we said that the probability of y is great because the total probability is 1. Okay, so it can either be greater than 2 or it's less than 2. Okay, so this probability that y is less than or equal to is exactly the same as saying, well, that includes y, remember. So it's the probability that y is less than or equal to 1. Okay, and it's 1 take away the probability that y is less than or equal to 1, because the probability that y is less than or equal to 1 plus the probability of y is greater than or equal to 2 is just the probability 1, because that's just saying any y value now. So you just rearrange it to say the probability of y is greater than 2 is 1 take the probability that y is less than 1 or equal to 1, and equal to 1, sorry. Okay, so you just sub that in. Now, I know we've got that in terms of y, not in terms of x, okay? But you just look in the table as though you're looking for x, because the only reason you've put y there is to make sense of flipping it on its head. Okay, so so if you wanted to work out the probability that x is less than 3, by the methods of calculation, what you'd now be looking at is 1 take away the probability that x is less than or equal to 1. Now, I've just substituted y for x because it's just to enable us to make the distinction that we are looking at it upside down in the other way around, if that makes sense. Okay, so then obviously you just work out your value for probability that x is less than or equal to 1 and sub it in. Okay, so 1 take away whatever that is and you would get your answer. Okay, so hopefully all of that makes a little bit of sense. If it doesn't, please do comment, obviously, weirdly enough, in the comments, and I'll obviously get back to and try to distinguish any little bits about this table you didn't get, or just get anything in general about the video so far you don't get. It's totally fine. Anything after though, it's stuffy. I'm obviously joking along. Okay, so the next little bit is very, very simple in comparison. Okay, it's simply just formulas. Now, don't think you're giving them. You might be giving them. Yeah, you're giving them. Okay, it's them values I was showing you before. Okay, now obviously that equation, the very first equation, it is sort of given you in here, but not really well. Okay, so for this, okay, binomial distribution, if we wanted to work out the mean would be equal to n times p. In other words, the number of trials times the probability of a successful trial. And that means, as we know from group data in S1, that's the expected value, okay? So this mean is also known as the expected value. And it might ask you to calculate, the expected value in an equation. Or it might ask you to rearrange this and say, what's the the mean of getting a 3, or the expected, what's the probability of, I don't know. Basically, you just need to associate the thing that expected value is also another way of saying the mean. Okay, so you might get questions which ask you to manipulate that equation. As I said, I will be doing some questions associated with normal distribution in my S2 playlist, but as I said, just be wary that they may get you to use that equation, just manipulate it, rearrange it. Okay, so that's one equation. And then obviously the variance is n times p times 1 minus p. Okay, that's just the variance formula. That's equal to the variance. And this is where your S1 knowledge comes in. You know that the standard deviation is equal to the square root of the variance, as the variance is equal to np times 1 take p. Okay, it's just the standard deviation is np times 1 take p, where p is the probability of a successful outcome and n is the number of trials. Okay, so that last little bit is very, very easy. As I said, it just applies to equations where you have to sub in numbers and rearrange. I don't think I need to go through that with it. It's just a case of manipulating questions. Basic algebra, which you've got to this stage in your maths career, perfectly acceptable, nothing challenging about that at all. So don't waste too much of your time on that, because as I said, it's very simple. There's nothing difficult about that at all. Okay, so thanks for watching. Hopefully it's been helpful, and we'll see you in the next video.